Hello, dear students. I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. Today, I'll discuss about the collection routes regarding this hall container system. In last class, I discussed about the hall container system and some problem statement regarding this hall container system. So, as we calculated the how much time operation will take, this hall container system operation will take. So now we will discuss about the collection routes, like which route should be preferred while designing a hall container system whole operation, because this route is very much important as the waste collection route from the its first point to end point, and that some point should be keep in mind while designing the route, like it should be not much heavy traffic area or no much congestion is there, or like that some things are there. So today we are going to discuss about the collection of routes. So first of all, this collection routes must be laid so both the workforce and equipments are used effectively. So first point is that thus some points to be followed while designing the routes, like if it will be in a good way, then that work should be effectively, like the operation and the equipment both will attached with each other, so it the work will this will work effectively. So the while the factors, the important factors we are going to discuss, that should be keep in mind while designing the routes. First of all, it is like existing regulation are there. So from the first point is the point of collection and frequency of collection should be there. Like the first thing keep in mind is collection point of this garbage and route frequency of collection. Frequency of collection is like that. So the that will be convenient for the whole operation. And the existing system condition, some data should be there, like existing system condition, like the crew size and the vehicle types, means which type of vehicle should be used for the collection of the garbage, because some places more waste generation is there. That's why the collection frequency and collection point is very much important. Like what is the frequency, means how much amount, what are the general trend for the garbage collection of that particular area. So if it is having a more amount of waste is there, so if more garbage is there, then the vehicle size should be big, or the crew members or the persons who are handling, who are doing some works, their amount should also be more. If it is a very less amount of waste is generated and the collection is also less, then automatically if less waste is there, then the collection should also be less, like once in a week, so the member should also be less. So in this types, these are the things that should be keep in mind while designing the route of a city. And a waste generated at a traffic congested area or should be collected as early in a day as possible. So to avoid unsanitary condition or to avoid nuisance, the waste collection should be done early in the morning, while the place, if it is a highly traffic congested place, so if it is a highly traffic congested place, then the it should be keep in mind, like the waste collection should did in early in the morning to avoid nuisance of the environment and to avoid some discomfort to the local persons also. Next point is that the source at which extremely large quantity of waste are generated should be serviced during the first part of the day. Means the place is there where the source, where the extremely large quantity of waste are generated. If more amount of waste are generated, so this should be served first part of the day. Like the same thing is there, if extremely or more amount of waste is generated from a particular place, then it should be done, that operation should be done early in the morning, when to avoid discomfort to the persons or discomfort to the people. So these are the important factors that should be keep in mind while designing a route for this hall container system. First is like that the point of collection, where the point of collection is there, and the collection frequency, means the frequency of waste generated, and the existing system condition, like what is the that existing system condition, and what is the crew size and which type of vehicles are using for that particular waste location. Next is the waste generated at traffic congested location. If it is having a very high traffic congested location, then it should be collected as early in the day as possible. It should be collected in the morning only. and source at which extremely large quantity of waste are generated. If any type of source is there where more amount of waste is generated, so what it should be do, it should be serviced during the early in the morning. So these are the same points that has been discussed about this whole container system, like in what way this operation should be effective, it should run effectively. So for this type of things, the some congested traffic congested area places there, or if more waste generated places there, like extremely large amount of waste is generated, then they should be served early in the morning or first half of the day, because this will be good for that particular location. Now comes to the next point. So you can see the pictures, like these are some pictures I bring, like this is the picture of a large load should be daily in the morning. See, this is the picture of a vehicle that are collecting the garbage. So what they're saying, like the if a large load is there, if more waste is there, they should be served in the morning only, because to avoid some traffic condition or to avoid discomfort to the people. So this type of this practice should be adopted for a good hall container system practice. Like this hall container system operation should be done, if it will be done early in the morning from the places where high waste content is there, where extreme amount of waste are generating. And this is a picture that is showing that the if large collection point, if last collection point is there, like last collection point should be nearby to the landfill site. Last collection point should be nearby to the landfill site. Because of only this operation should be run effectively. So scattered point where small quantities of solid waste are generated should, if possible, will be serviced during one trip on the same day. So this type of if you plan like a route is like that, scattered small quantities of solid waste points are there, and that should be serviced during one trip or on the same day. That should be served by these peoples on the if on the same point. And to avoid any type of nuisance, any type of unsanitary condition, this should be keep in mind. So this operation will run effectively, like in a single way, the more pickup points they should followed, or the last solid waste collection point should be there, which is nearby to the landfill site. So these are some points that we are discussing while designing the route for an effective integrated solid waste management system. If a city is adopting this hall container system, so many points are important, but the main point is that collection route is again an important point, because the collection route will decide which path to follow. If it will follow efficiently, effectively good path, then automatically the nuisance or something that will be the discomfort will be reduced. That's why to bring this operation effectively, these are some important points that should be keep in mind while designing the routes. Now comes to the four point we are going to discuss. That is four point that is related with the layout of the route. Layout of the route for first point is that prepare a location map. Prepare a location map, like, and in this map what you have to follow, we have to follow, first one is the location, means which type of location is there. Next is the number of container, means how much amount of container you needed, number of container, and then collection frequency. So these 3 points are very important point that should be followed while designing a route. First, you have to prepare a layout of the route, and in this route layout you have to discuss the location type. Like this, it is a highly traffic location area, or it is a highly congested area, or it is having a more population density area, which type of area is there. And according to that, the containers numbers has been increased. Like if it is a more populous area, then containers will be more. If that place is a less populous area, then container will be less. And on the basis of container, the collection frequency also decided, because if more containers you are installing, it is a big society, then you will install 3 to 4 containers, then that waste collection should be in a weekly twice or thrice, then this type of system will work. Or if it is a very less populous area, like a very few homes are there, then the container sizes, number of containers will be less, like one or two. So if one container is there, then obviously the collection frequency will also reduce, like once in a weekly they will come for to do this whole operation. Next point is the prepare a data summary. Prepare a data summary. How to prepare this data summary? Data summary means what? Estimate the quantity of waste generated from pickup location that service each day, and where the stationary system is used, and number of pickup cycle must also be determined. So prepare a data that will summarize how much time, or how many time that service should be required, and what are the number of pickup cycle that should be determined, and how much this pickup cycle should be adopted, like about how much how frequency you need, and with this pickup time you need. And third point is the layout of the preliminary collection. Preliminary collection means collection at the doorstep, set out setback collection, either alley collection method, or the door to door collection method, which type of method adopted from that particular municipality. So their preliminary collections should be starting from the dispatch location, because from dispatch location they should start their pickup collection route, and a route should be laid out to, so that it will connect all the pickup location. Route should be like that, it will connect all the pickup location, and that will be served during each collection day. Means like when this collection will start, on each collection day they will serve all the pickup places. So all the pickup places each collection day, route should be laid that connect all pickup location. Route should be like that, that will connect all pickup location, all pickup location. And how it is possible, like all pickup locations should be collected, and the route should be laid so that the last location is nearby to the disposal site. Last location is nearby to a dump site. Last location should be nearby to the disposal site, or MRF site, or whatever site is there, landfill is there. So this will be a last location, and that last location is just nearby to the landfill. And then what you have to do, develop the balanced route. Like after preliminary collection, route has been laid out, the whole distance for each route should be determined. Then the after this preliminary collection, the whole distance should be measured. After this preliminary collection, the whole operation should be measured. Whole operation should be determined like this. This will be like develop a balanced route. In this way you can develop the balanced route, like what route should be followed for this preliminary collection for the hauling operation. Now comes to the next point. We are going to discuss about a problem statement. This problem statement, where we have to calculate the collection vehicles, means how much collection vehicle is required to serve 4,000 persons. So this what this problem statement is saying, calculate the number of collection vehicles a community would need if it has 4,000 services that are to be collected once per week during working days in a city of Iraq. So this is the problem statement where you have to calculate how much number of trucks is required to serve 4,000 people. A community is there where 4,000 people are staying. So to serve these 4,000 persons, how much amount of truck is required? So n is equal to n, we have to calculate like the number of collection vehicle needed, how much collection vehicle is needed. So and s is the total amount of customer service, means total how much customer you are served. So s is equal to 4,000, n is equal to what we have to calculate. And then collection frequency, like number of collection per week. Number of collection should be one time in a week, once per week during working days, and it is during working days also, not on the Sundays. So X is equal to number of customer a single truck can service per day. So a single truck can service per day 300 customers. So this has been given like in the question, like X is equal to 300. Generally, one truck can serve 3000 of customer. So if in a single trip, so like this, we'll calculate this by the formula. N is equal to, and we have to calculate SF into XW is equal to 4,000 customer you have to serve into one, because once in a weekly, and then it should be 300 capacity of the whole truck into 4, because 4 3s are 12, and it will come like 3.3. So 3.3 means approximately it needs 4 truck. Tuesday leaving Wednesday for special project and truck maintenance. So, and the town wants to collect on Saturday and Sunday and Monday. So 3 working days they want to collect, and 4 days they required for the some truck maintenance or something, or for the route special project, some other projects. That way 300 into 4. So in this way we can calculate to serve 4,000 of persons, 4,000 of person, 4 truck is required for a single community. Like if 4,000 person is there, so if we will calculate how much amount of waste generated, so it is half kg of waste, as it has been already given in the data, like a person is generating half kg of waste in a day. So this operation, if you will do operation, this hall container system operation, this hall container system operation, if you will do twice in a weekly, then 4 truck is required to serve 4,000 person in a community. So this it has been fixed that this community needs 4 trucks, like 4 to serve 4,000 of person. Now comes to the next problem statement that has been related with the layout of the collection route for a residential area. So if we are designing collection route for a residential area, like this residential area is there, and you can see this is a picture of a layout of a residential area, where some houses are like this 2 6 and 12 type of blocks are there. 2 6 12, this type of blocks are there. So if you can see this type of blocks, 2 and 6 blocks are of 10 numbers. You can see this type of blocks is of 10 number. Like in a apartment, 2 blocks are there, and then 16 16 6 6 blocks are there. So in this way 6 6 12 plus 4, 16 blocks are there in a single apartment. Like this 10 houses are there, and 4 houses is having same type of, 4 houses is having same type of layout, like they are having 6 residents, 6 6 and 12 12 residents. So 4 is having same type of layout, one is having different type of layout, one is having different type of layout, like 2 12 12 and 2, this type of layout. So mainly the blocks are there in each residence is like 2 6 or 12. So to serve this building, how you will design the route, so they will cover maximum points, or they that collection people will cover maximum point, and that will be sufficient, for this particular area. So first we have to keep in mind like how much persons are there and how much amount of waste they are generating. So this for making a layout of the collection route for this residential area, let's start this discussion. Like first of all, what you have to think like this: the service map area would be prepared as the first step in the layout collection route. Assume the following condition apply. So first, what you have to do, like occupant per residence, like per residence, as 3.5 members are there in a per house, and the solid waste collection rate is equal to 1.56 kg per capita per day. Means a single person is generating 1.6 kg of waste in a per day, and the collection frequency is once in a week, once in a week. And the collection system is the curve collection system methods they are adopting. In the curve system method, what they are doing, they are putting their garbage to one curve, one container that has been installed in that place, and this hall container system people will municipal people will come and they will collect from each pickup point. And collection crew size, in a crew size is the only one person is there with this hall container operation system. Next is the capacity of the vehicle is 10.7 meter cube, and the compacted is specific weight, means if by doing compaction how much specific weight that can be hold in the truck, in the collection vehicle, it is 320 kg per meter cube. And what is the constraint we should keep in mind while designing the route? No u-turn is there in the street. In the street no u-turn is there, and the collection from each side of the street with stand up right, like collection curb collection method is there, so that all container is installed in the right only, and the hand driven collection vehicle, like a right hand collection driven vehicle is also there, and the containers that has been installed in the right side. Now first of all we'll calculate how much person are living in this particular layout. So development of data is needed to establish the collection route. Determination of total number of residents from which waste are to be collected. So determination of total number of residents. So as we know that this type of house is of 10 numbers, so in 10 numbers 16 uh, residents are there. Like this type of house is 4 number, this green color, and in this 36 residents are there. And this type of house is 1, it is of 28 persons are there. So if we will calculate, we will find that 332 whole families are living in that society. From that location 332 families are living. So now comes to the next point, that is we have to calculate the volume, determination of compacted volume of solid waste to be collected per week. So first we'll determine the compacted solid waste, means how much amount of waste is generated by the persons or the residents living in that area, and how much amount of solid waste generated, plus how much they need for compacted volume of solid waste to be, if it will be collect in a per week. So volume per week is equal to residents into occupants per residence into solid waste collection rate. Residence means like 332 persons are living there, and occupant per resident, as we have already assumed that 3.5 persons in a per family, in a per residence, in a per house, into solid waste collection rate. Solid waste collection rate is 1.6 kg per capita in a day, and 7 days per week. 7 days in a week. So, and the it is already given the capacity of the vehicle specific for the specific weight of solid waste is 320 kg per meter cube. So in this way, we'll calculate that the compacted volume is a 40.6 centimeter. Compacted volume of the solid waste to be collected per week is 40.67 meter cube. So from that residence, from that area, total amount of solid waste, compacted solid waste is the 4.7 meter cube. So this much capacity of solid waste can be taken by the vehicle, those vehicle that are coming to collect waste from that area. 14.67 meter cube of waste they can be hauled. So now we have to calculate the number of trip required per week. In a per week, how much time, how much trip is required to calculate the waste, because of with their capacity of the vehicle, capacity of the collection vehicle, and the capacity of collection vehicle is equal to 10.7, and the compacted volume of solid waste collected, compacted volume of solid waste for that area, volume of solid waste, so is equal to 40.67. So how it can be calculated? 40.67 upon 10.7 is equal to 3.8, like 4. 4 number of trip is required in a single week. In a week, with this vehicle, with this capacity of collection vehicle, with this solid waste generation rate, 4 times trip is required to collect all the solid waste from this particular layout. Now comes to the next point, that is, now we can develop this type of route, like how we'll develop, like 332 residents are there, and 4 times the trip is required. So residence is the 332 divided by 4, like a trip Total trip, 4 trip is required, so is equal to 83. 83 is the answer, which the average number of residents from which waste are to be collected. So in a single day, this much of the waste is collected. So you now we can develop this type of route, like route 1. Route 1 is a starting point. Route 1 starting point is there. So if vehicle, you can see that the dark line is the route of the vehicle, and the dotted line is no collection. No collection is there. So they are doing right hand collection only, right hand collection with right hand driven vehicle, and a person is only one crew member is there. So if it will be starting with this line, and the dotted line is there, means no collection, then in this person they will come to this next block. In this block they will start this clockwise system, and then this vehicle will go to the next block, and while this block, it will come directly to this block, and this block it will collect right hand method side like this, and then again it will go to the this route, and this route is a dotted, means no collection. Again it started collecting all the garbages like this, and then dotted is no collection, no collection is there. Again it is going like this, and here it is the end of route 1. End of route 1. Route 1 ends. Route ends. Now the next route is the route starting of the route 2. Starting point of route 2. Starting point of route 2. Route 2 is starting from this point, where you can see that route is starting with this. This is the starting point. Here they are trying. This is again a clockwise direction, and they are trying to do more collection. So this arrow, you can see that they are going like this. They are doing the collection in this big apartment, and then this route is followed. Here again they'll cover maximum apartments, because in the route 2 the houses is having more capacity. So like this, the dotted is no collection point, like this here it is the end of route 2. So both the route has been end nearby to the MRF location site or landfill site. Both the route ends at nearby to the landfill site, and this is the route. This is the end start of route 2, and this is end of route 2. This is the end of route 1 also. So like this, the waste collection, the waste frequency to for taken it into to the MRF location, it is very much nearby. And this type of, by this you can develop the layout for a city or for an apartment, how to do this collection of the solid waste, and to avoid nuisance, and to cover more and more pickup points in a single trip. So for this layout, for this building layout, we have developed this route. Like this route, the trip should be 4 times in a week, and they are on an average, they are going to determine the average of the residents, like 83 average residents are there, which should be collected on a single each collection trip. Each collection trip, they are means on an average they are focusing 83 members is there. So this will be the end of the route, and already I have discussed this problem statement regarding this layout of the route collection system, and this was so I'm concluding my lecture on this layout of the collection route. Next I'll discuss about some numericals methods on this comparison between both type of hull container system, like conventional hull container system or exchange mode hull container system, which one is better. So I'll discuss it in the next class, and regarding this class I'm concluding my lecture. If you have any doubt or query, you will write in the comment box, or you can directly mail me on my given mail id, shikha.panday@gmail.com. You can directly mail me on the mail id, and thank you for today's lecture.
Like, share and subscribe. Hit the bell icon for more updates.